As part of my problem series, in this video, I will be calculating current using Thevenin's theorem. Once I am finished with this series of problems, I'll be posting them in my StanStore at this web address. Before proceeding, I want to explain the three web addresses that you will be directed to using. You have already seen the first here. This is a web address of my StanStore, which will give you direct access to all of my electrical courses. On the last page, you'll find an address that will direct you to obtaining the 50-page crib sheet and notes that will not only be handy when you're taking my courses in my StanStore, but also for reference during any time during your career. Here you'll also be asked for your email address, which will not be shared with anybody or distributed in any way, but it will allow me to keep in touch with you and let you know of any additions or updates to my courses and or blogs. Near the end of the video, I'll be introducing you to a supplier of electrical products, which in my estimation are of value worth paying attention to. Our task in this problem is to calculate the value of the current IL through the resistor RL in this DC network using Thevenin's theorem. Thevenin's theorem states that any two-terminal linear network containing resistances and sources of EMF and current may be replaced by a single source of EMF in series with a single resistance. The EMF of the single source will be called ETH at the network terminals A and B. The single series resistance, called RTH, is the resistance between the network terminals A and B when all the independent sources are replaced by their internal resistances. When the Thevenin equivalent circuit is determined for a network, the process is known as Thevenizing. When Thevenizing the circuit to find Thevenin's voltage ETH, the load resistor is removed. The open circuit terminal voltage of the network is calculated. This value is ETH. Because no current can flow through R3, the voltage ETH is the same as the voltage across resistor R2. Using the voltage divider rule, we find that ETH is equal to 100 volts times the quantity 100 divided by the quantity 100 plus 100. And that is equal to 50 volts. Next, when Thevenizing the circuit, we find the Thevenin resistance, RTH. The network is redrawn with the source of EMF replaced by a short circuit. If a current source is present, it would be replaced by an open circuit. The resistance of the redrawn network, as seen by looking back into the network from the load terminals, is calculated. We call this value RTH, where RTH is equal to 50 ohms plus the quantity 100 ohms in parallel with 100 ohms, which ultimately calculates to 100 ohms. The Thevenin equivalent circuit consists of the series combination of ETH and RTH. The load resistor RL is connected or reconnected across the output terminals of this equivalent circuit. RT, the total circuit resistance, is made up of RTH plus RL, which is equal to 100 plus 50, which is equal to 150 ohms. And in order to calculate the current IL, it is equal to ETH divided by RT, the total load circuit load, which is equal to 50 divided by 150, ultimately equal to 1/3 amps. With respect to the terminals only, the Thevenin circuit is the equivalent to the original linear network. Changes in RL does not require any recalculations for this new Thevenin circuit. The simple series Thevenin circuit can be used over and over to solve for load currents each time RL is changed. I want to introduce you to another product that's out there that is worthy of paying attention to, the 𝐃𝐈𝐒𝐂𝐋𝐀 F2000 generator. To find out more about this battery generator and to keep up to date on any sales or discounts that are available, simply go to the Anchor site at this web address. And by using this web address, you can get $800 off the original price, or just browse through the various options on this site. There is no charge for just looking, but you might find something that is available at a discounted price at this particular time. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.